We're going to learn an important concept in chemistry right now called the mole. Mass is very hard to use in chemistry, and that's because every element has a different mass. So it's hard to compare one element to another. So if you look on your periodic table that you use, you should try and find the mass number, and we'll use carbon to help you find the mass number and where it is. If you look at my carbon here, up above is a number that says 12.01. This is the mass of 1 mole of carbon. Now, I'll explain what 1 mole means in a little bit. But what we do when we get these mass numbers or atomic weights, that they go by different names, we round them to whole numbers. So I round carbon to 12. As you can see, the mass of hydrogen is 1. The mass of carbon is 12. Carbon's 12 times heavier than hydrogen. Now this number here is the atomic number, so that tells us which number it is on the periodic table. This is the first element, this is the sixth, and it's based on the number of protons that it has. So right now we know that 1 mole of hydrogen weighs 1 gram, 1 mole of carbon weighs 12 grams. Well, what is 1 mole? Well, let's talk about a dozen first. A dozen is 12. Or if you got paper for the photocopier, they come in packages of 500, which are called reams. Our dozen in chemistry is a very large number. It's 6.02 times 10 to the 23. If you're going to enter this in your calculator, you go 6.02. You do not hit the times button. You hit the EXP or EE button, and then 23. This number is huge. You could not count up to this number. If you started counting from the time you were born, you wouldn't even get close to counting up to this number right here. It's very important that you can enter this number in your calculator, so make sure that you try that. It's either 6.02 EXP23 or 6.02 EE23. Now, if you have a dozen donuts, you have 12 donuts. If you have a mole of carbon, you would have this many carbon atoms. Why would they choose a number that high? That number of carbon atoms would fit comfortably in the palm of your hand. If you had 5 moles of water, or 5 times as many particles of water, you could fit that inside of your mouth. Okay, so the first thing that you have to be able to do in U4A1 is understand that a mole is a number of any chemical that we choose to look at, and that it is a reasonable amount. Even though the number's large, it's enough to fit comfortably in your hand. So if we want to know how much 1 mole of carbon weighs, we look up its molar mass in the periodic table. We round it 12 grams. If we want to know how much 1 mole of water weighs, we look up the mass of hydrogen. It rounds to 1 gram. There's 2 of them. Plus there is 1 oxygen, so we look up oxygen, and oxygen rounds out to 16 grams. If we add all of that up, the molar mass of 1 mole, or the mass of 1 mole of water, is 18 grams. Folks, this is used a lot in chemistry. Let's try one more molecule. We got methane, CH4. We look up carbon, 12 grams. We look up hydrogen. We have 4 of them there, so we have to have them all. That's 16 grams for 1 mole of methane. Once again, the reason that this is so important in chemistry is we can't use masses directly in chemistry. And the reason we can't is because you can see every chemical has its own mass. Okay, it'd be like putting a football team on the field and saying we're going to have 1,000 kilograms of players on the field. We don't do that. We say we have X number of players, whether that's 10 or 11. And that's because everybody's going to weigh a different mass.